Hi, now we'll discuss about the Newton's laws of motion chapter. So first one, force. It is a physical quantity which either causes change in configuration, then change in motion, or it tends to cause the change in motion. So R, force is nothing but the pulling or pushing of an object is called force. Then here force is change state of motion. So here this object is at rest and the person is pushing, so from the rest to motion. And similarly force is this is required from the motion of the object to become a rest. And similarly the force is tendency to cause the change in motion. And force is the change the configuration. So here initially this is flat. Now the person is applying force, then the configuration of this is changes. And here what is Newton's first law of motion? Newton's first law of motion is nothing but that is a body at rest continues to remains at rest, and a body in motion continues to move in a uniform velocity until and unless an external force acts on it. So here calculate the net force acting on a car moving with a constant velocity 30 km per hour on a rough road. So the car moves with a constant velocity. Now here in this case the body moves with constant velocity. So here that is in the uniform motion. So there is no change in state of motion because the car continues to move with the same velocity. So by the Newton's first law of motion, the net force acting on the car is 0. And here next, inertia. Inertia is the property of opposition to change in state of motion. So inertia is inertia of rest. Next here that is inertia of motion, right? This what is the inertia of motion? The property of opposition to change in state of motion, that is inertia of motion. Next inertia is the property of opposition to change in state of motion, that is, so finally inertia of rest and inertia of motion and inertia of direction. Next mass is the measure of inertia. So here this is a 10 kg mass and this is a 100 kg mass. So for both the same masses to move the displacement d, for this 10 kg mass 10 Newton is required, and similarly for the 100 kg mass 100 Newton is required. So which one has more inertia? 100 kg mass is the more inertia. So mass is the measure of inertia. Next, when a carpet is beaten with a stick, dust comes out of it. Then explain. So here both carpet and initially both carpet and the particles are at rest. Now in the case of rest, both carpet and dust particles are at rest. So in the case of rest, carpet is beaten and it comes to motion. So carpet is in a motion, but the dust particles try to remain at its own position, that is at rest. And similarly, why are the passengers thrown backwards when a stationary bus suddenly speeds up? So here this is the bus and passengers are at rest. And next in the case of rest, so the upper part of the body and the lower part of the body both are at rest. Now here the bus is moves and the bottommost point, that is the contact point between the bus and the man foot is that is in a moving forward direction. That's why the topmost point at the upper position of the person is at rest and the lower position of the person is moving. So that's why that person is falls backward direction. So here lower part body comes to motion, bus suddenly speeds up in the left direction, lower part comes to motion, then lower part is come to motion. As a result, passengers are thrown backwards. Now here we will discuss about the Newton's second law of motion. If a net force is acting on an object, then the object will accelerate. So here this is fan. This fan is accelerate because the air force is acting on this fan. So here if net force in an object, the object will accelerate. The acceleration depends upon the directly proportional to the net force. The acceleration A is depends on directly proportional to the net external force and that acceleration is inversely proportional to the mass. So here A is equal to F net divided by M. So here acceleration proportional to net force and inversely proportional to the mass. So from this F net is equal to MA. This is the Newton's second law of motion. Net force acting on an object. That net force is net external force, not internal force. The net external force acts on an object is equal to mass of the body into acceleration of the body. Here this is valid only when mass of a body is constant, then only Newton's second law F net is equal to mass into acceleration. So here we know that acceleration is equal to change in velocity by time. So F net is equal to m into v minus u divided by t. So that is mv minus mu, where mass into velocity is nothing but the momentum. So final momentum minus initial momentum divided by delta t. This is the net external force. Now here, so the rate of change of momentum of a body is directly proportional to the net applied force and takes place in the direction in which the force acts. So that acceleration is directly proportional to the net force and that acceleration is inversely proportional to the mass of the object. So acceleration A is equal to net force by mass. That is, acceleration A is equal to net force by mass, and that force is equal to change in momentum divided by delta t. F net is equal to delta p by delta t. This is the original form of the Newton's second law of motion. Then here Newton's third law of motion. For every action there is always an equal and opposite reaction. So here initially the object is at rest. Here mutual force of same nature arises on both bodies. So here on this Newton's third law of motion, mutual forces are acting. So here the forces are equal in magnitude and opposite in direction, because they, in the Newton's third law of motion, this action force and reaction force are acting on object, but the action and reaction force are acting on the two different bodies. So here forces acting on opposite direction, that forces don't cancel each other because that they act on two different bodies. So here why the boat moves back, because the person jumps here, why the boat moves back? When the sailor jumps in forward direction, the boat moves back. Here sailor jumps out of from the boat, and if sailor jumps out of from boat, presses the boat with feet here. So by third law there will be an equal and opposite reaction forces. So here presses the boat with feet, that is a action force, and by third law there will be an equal and opposite reaction force acting. So next, the earth pulls a stone downwards due to gravity. That the stone exerts a force on the earth. So this is earth and object. So here the earth exerts a force on the object and the object also exerts a forces in the same direction. But see, yes, here according to Newton's third law of motion, the stone does exert an equal and opposite force on the earth. We do not notice since the earth is very massive and the effect of a small force on its motion is negligible. And next, what is impulse? The impulse is nothing but that is a force, impulsive force. It is a large force acting in a small interval of time, then that is called impulsive force. So what is impulse? Impulse is equal to force into time duration. Impulse is equal to change in momentum. So here a batsman hits a ball straight in the direction of the bowler without changing its initial speed of 10 meters per second. If the mass of the ball is 0.12 kg, determine the impulsive imparted to the ball, assuming linear motion of the ball. So here the given initial velocity is minus 10 meters per second, final velocity is 10 meters per second, because velocity is a vector quantity. Take one direction is positive and another direction is negative here. So here what is change in momentum? Final momentum minus initial momentum. Final momentum is final velocity, final mass into final velocity minus initial velocity, mass into velocity. So here we consider as towards the right, initial direction is considered as a negative and this direction we consider as a negative. So this is we consider as a negative and this is we consider as a positive. So here what is Initial momentum is what? Initial momentum. Initial momentum is, this is negative. So in this case, initial momentum is equal to this mass 0.12 into that velocity is minus 10. This is the initial momentum and this is the final momentum, because left side we assume like a positive. So that is change in momentum. So here change in momentum is equal to 2.4 Newton second. So impulse is equal to 2.4 Newton second in the direction from the batsman to the bowler. And here a batsman deflects a ball by an angle of 45 degrees without changing its initial speed, which is equal to 54 km per hour. What is the impulse imparted to the ball? So in this case, this is the incident path of the ball. This is U, and this is the final path of the ball. This is the angle between initial path and final path is 45 degree. But here makes an angle with a normal, that is 22.5 degree, and this is also 22.5 degree. So here mass of the body 0.1 kg, and in this type of problem, first this is mass, you is assume this mass is m, mass of the ball is m, and here this initial velocity is u, and here this is same velocity. So here you resolve initial momentum, you resolve. How to resolve initial momentum? Because this is mu cos theta in this direction. This is mu into, suppose assume like this angle is theta, this is mu cos theta, and here in this direction, that is m into u into sin theta. This is the initial momentum resolution, and similarly final momentum resolution. So this is mass into velocity. In this direction, this is m into u cos theta, and similarly in this direction is m into u sin theta. So in the vertical direction, initial momentum is mu sin theta in the downward direction, and in finally vertical momentum is m into u sin theta downward direction only. So change in momentum in the vertical direction is equal to 0. Now the change in momentum along x direction is, change in momentum is equal to final momentum minus initial momentum. This is initial momentum along x direction, mu cos theta. This is the final momentum along x direction minus mu cos theta, and similarly initial momentum along y direction is minus mu sin theta, and initial momentum along and final momentum along y direction is minus mu into sin theta. So here finally change in momentum in x direction is minus 2 mu cos theta, and similarly change in momentum along y direction is 0. So impulse imparted to the ball is equal to change in momentum, that change in momentum minus 2 mu cos theta. Substitution this above values, then you will get the 4.14 kg per second. Next, common forces in mechanics. So here this is very important topic in the Newton's laws of motion. Common forces, first weight. Each and every body has a weight. That weight is acting always vertically downward direction. This is the mass of the body, and this mass has a weight, mg, is acting vertically downward direction. So whenever mass of the body is always acting vertically downward direction, weight. And next, similarly, this is a object is placed on the surface of the earth. Okay, this surface of the earth, the object is placed. Then what will happen here? The object, weight of the object is acting vertically downward direction. So here weight is acting vertically downward direction, and this surface exerts a pushing force in the upward direction. That is normal reaction. That name of that force is called normal reaction. This normal reaction is always pushes the body, like this is a pushing. And this normal reaction force is always perpendicular to the surface. So here the earth exerts a force on this body, normal reaction upward direction, and the body exerts the force normal reaction in the downward direction, because these two forces are action reaction forces. And here, suppose on this body of mass m, and the external force acting on the body is capital F, that is acting towards the right. So because of the external force is acting, the frictional force acting on the object, that is F, towards small f, that frictional force indicated by the symbol is small f, that is acting towards left. So here external force, and then frictional force is in backward direction. So this is the external force, and here this is the frictional force acting on the object. Next, tension. So here this is the mass of the body and its weight is acting vertically downward direction, its weight, but here this is a thread. So the force acting in a thread is called, that is a tension. So tension is a pulling force that is acting always. The tension force is always acting from the body to the outside, that force is acting, like tension force is acting in this direction, like this direction, tension. Tension force is always acting from the body to the outside. So this is the tension. So next spring force. So here the spring and the body is placed on this, body is placed like this. So here this is the surface of this is surface, and m mass of the body is acting on this body. Then here what will happen? Some external force acting on this object, that is, this is the initial length of the spring, and here some external force acting on the object. Then what will happen? The spring will compress a displacement x. This is the displacement of x. Now here this spring force acting on this object, that is opposite to the direction of displacement of the body. So here the body displaces towards right. So spring force acting on this object is towards right. The external force is acting towards left. So the spring force is acting towards right. So spring force is always acting opposite to the direction of displacement of the body. So here what is meaning of x? Here x is the compression in the spring. Suppose initially length of the spring is 10 centimeter and finally that length of the spring is suppose 8 centimeter. Here x is nothing but 2 centimeter. That is the compression in a spring, where x is compression. In some other cases, suppose like this is body, this is the spring. In this case, the spring length is 10 centimeter and external force is acting like this. Then what will happen? The spring will elongate. In this case, the spring is elongation. So this elongation is nothing but x. So in this case also, the spring force acting on the object, that spring force F is, that is opposite to the direction of the displacement of the body. So here body displaces towards the right. So spring force is acting towards left. That is, this is the spring force. What is x here? Initially suppose length of the spring is 10 centimeter. Suppose finally the length of the spring is suppose 11 centimeter. Now in this case what is the length? X is what? That is 1 centimeter is the elongation in a spring. So finally spring force magnitude is equal to k into x, where k is called spring constant. Different springs having different spring constants. X is elongation or compression in a spring. That is depends on the direction of the applied force. Next, free body diagram. What is the free body diagram? Free body diagram means here first you decide a system. A system is that part of a body in which we are interested. So here steps to draw a free body diagram. What are the steps? First, draw a sketch of the situation. What is the situation? Draw the entire situation. You draw one sketch, rough sketch. Then here, suppose this is mass of the body is placed on the surface of the earth m. Now here this m and draw and separately you and here this small m mass is separated from that system. So here this mass m is separated. Then here identify the external forces acting on the system. On this body represent all external forces acting on the object. In the free body diagram represent all forces acting on the object, not by the object. So here this mg is acting downward direction and normal reaction force is acting. Suppose here a mass m is placed. Now first separate the body from the diagram, and here body separated, mg acting vertically downward direction, and here this surface exerts a force on this object, that is called normal reaction. This is the free body diagram of this mass m of the body. And here a block of mass m is suspended with two strings as shown in the figure. Draw the free body diagram of the block. So here this mass m, this is the mass of the body, and here this is one string and here this is one string. Assuming the tension in this string is T1 and this is tension in the string is T2, how to draw the free body diagram of this body M? So here first separate the body from the diagram. So say separated body from the diagram, and this is mass is M, and here mg is acting which direction? Mg is acting downward direction, this is mg, and here this is tension T1. Tension is always away from the body. So here T1 is acting towards left, and here T2 acting in this direction. This is the T2. This is the free body diagram of this block. And here in this case, draw the free body diagram of both the masses and pulley for the given sketch. So in this case, the free body diagram of this body mass, assume like this mass is M1 and this mass is M2. So how to draw the free body diagram of this body? First separate the body from the diagram. So here I am writing M1 is here. So M1 free body diagram. What are the forces? Represent all forces acting on M1 and represent all forces acting on M2. So here M1G acting vertically downward direction, and this normal reaction force is acting in this direction, tension is acting in this direction. So this is a T, tension T. But here this is only one single string. So tension each and everywhere, tension remains same. And similarly M2 free body diagram, on this M2 free body diagram, M2G is acting because weight is acting downward direction, and tension, here also tension is always away from the body. So this is a thread here, in this case tension is acting in this direction, that is T. Next, what is the meaning of the equilibrium of a particle? Equilibrium means the net external force acting on an object is equal to 0, then that is called equilibrium. So in this equilibrium of a particle in mechanics refers to the situation where the net external force acting on the particle is 0. So here F net is equal to 0. Suppose example, suppose this body of mass M, on this body F1 force acting in this direction, F2 force acting in this direction, and F3 force acting in this direction. The sum of the all forces F1 bar, F2 bar and F3 bar, summation of the all forces F1 bar plus F2 bar plus F3 bar is equal to 0, then the body is in equilibrium. Means, so here that is F1 bar plus F2 bar plus F3 bar is equal to 0. So now you resolve this all forces F1x, F1 bar, write in terms of vectors. F1x I cap plus F1y j cap plus F1z k cap, like that. Similarly F2 and F3, summation will give the 0, that is the equilibrium. All the net force along x direction and net force along y direction and net force along z direction is equal to 0. That is the equilibrium of a particle. Suppose here a block of weight 100 Newton, this weight of this body is how much? 100 Newton, is suspended from a rope tied to other ropes at point O. This is one rope and this is another rope. The angle between the ceiling, this is the ceiling, and the rope is 60 degree. The angle is 60 degree. What are the tensions in each of the ropes? So tension in this rope is how much and tension in this rope is how much? That is the question. So here this angle is how much? That angle is 60 degree. Okay, this angle is 60 degree. Now how to solve this type of questions? So here first draw the free body diagram of a body. This, suppose here, and this is on body, this force is assumed like this is a tension T1 and this is a tension T2 and here this is a tension T3. So resolve this tension T1, this angle is given 60 degree in the question. So if that angle is 60 and this angle is also 60 degree, so this is how much tension. Now resolve this tension, T1 cos 60 in this direction, T1 sin 60 in this direction, and here that is the T3 and this is the T2. Now equate all forces. Positive direction, net force acting along the x direction is equal to 0, and similarly net force acting on the y direction is also 0. So here net force along x direction is how much? T1 cos 60 minus T2 is equal to 0. So T1 cos 60 is equal to T2. And similarly, T1 sin 60 is equal to T3. T1 sin 60 is equal to T3. But here, what is T3? T3 is acting, that is W. So this is the T3 is equal to W, that is the weight. So T3 is nothing but 100 Newton. So from this, T1 is equal to 115.47, T2 is equal to 57.73 second. So here in this question, this is the T1, see here, this is T1 and this is T2 and this is T3. So here T3 is nothing but, because this weight of the body, that is at rest, so T3 is equal to what? That is T3 is equal to W. Okay? T3 is equal to W in this case. Next, problems on Newton's second law of motion. What are the problems on Newton's second law? What is Newton's second law? F net is equal to mass of the body into acceleration of the body. So here, a stone of mass 0.05 kg is thrown vertically upwards. Give the direction and magnitude of the net force on the stone during its upward motion and during its downward motion. Do your answer change if the stone was thrown at an angle of 45 degree with the horizontal direction? So here, first body is moving upward direction. So what is the net force acting on the body? Net force acting on the body is mg. That is stone. Net force is mg. That is equal to m is 0.05 into g is 10. So 0.5 Newton acting downward direction. And similarly, body is moving upward direction. In this case also, the acceleration of the body is acting vertical downward direction. That is F is equal to m into a is g is 10. So 0.5 Newton. And similarly, body projected at an angle 45 degree with the horizontal. Now in this case also, the net force acting on the body is mg acting vertically downward direction. There is no component of this acceleration along horizontal direction. So the net force acting on the body in this case is also, that is mg. And next, a body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton, that is 6 Newton. Give the magnitude and direction of the acceleration of the body. So here this is 6 Newton and this is 8 Newton. Now calculate first net force acting on the object. What is net force? Because these two are perpendicular to each other. Net force is equal to root of F1 square plus F2 square. That is equal to 8 square plus 6 square. That is equal to 10 Newton is the net force. Now what is the acceleration of this? Acceleration acting on the object is, acceleration A is equal to net force divided by total mass. So that is equal to 10 divided by mass is 5, 2 meter per second square is the acceleration. So here, what is the angle? This angle, tan theta is equal to 8 by 6. So theta is equal to how much? That is 53 degree with the 6 Newton force. Next, the driver of a three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds just in time to save the child. What is the average retarding force on the vehicle? The mass of the three-wheeler is 400 kg and the mass of the driver is 65 kg. So this question, first identify what is the mass. Total mass is how much? 400 plus 65, 465. Initial velocity is how much? 36 km per hour. That is 36 is nothing but, that is 36 km per hour is nothing but 10 meter per second. So final velocity is 0. Then t is equal to 4 seconds. Acceleration A is equal to v minus u divided by t. That is the acceleration. So acceleration is equal to minus 2.5 meter per second square is the acceleration. Now what is the retarding force? Retarding force F is equal to m into A. That is mass is 465 into minus 2.5. That is equal to 1.2 into 10 to the power of 3 Newton. This is the magnitude of this force is this, and total force is that you will get a negative, because that negative sign indicate that that force is a retarding force. And next question, two blocks of equal mass m are tied to each other using a light inextensible string. One of the block is pulled along the line joining them with a constant force F. Find the tension in the string joining the blocks. So here this is object A and this is object B, and between these two objects a string is there, then external force acting on the object. Now here this first draw free body diagram of these two bodies. What is the free body diagram of A and what is the free body diagram of B? Draw free body diagram of A. So this F external force is acting towards the right and tension T is acting towards the left, and mg is acting vertical downward direction and normal reaction force is acting vertical upward direction. Now here write Newton's second law of motion for this object, that is, and similarly for B block also, what is the free body diagram? So here in this B block, this is a tension and tension T is acting towards the right and mg is acting vertical downward direction, and here normal reaction acting on this object is NB, that is acting upward direction. So here this normal reaction is acting NA and this normal reaction is acting NB. So here write Newton's second law of motion on the first object. What is net force? F minus T is equal to mass into acceleration. That is F minus T is equal to m into A. And what is the net force acting on the second body? That is T only. T is equal to mass into acceleration. T is equal to m into A. So here the vertical direction forces NA and mg, those are not participated in the acceleration. The acceleration of the body is only along horizontal direction. But here the vertical direction forces are also acting, but those forces are cancel each other. What is the meaning of the cancel each other? The upward direction force and downward direction force both are equal magnitudes and the opposite direction. So that's why the object is not moving in the vertical upward direction. So the object is moving only along horizontal direction, means the acceleration of the body is along horizontal direction. So that's why what is the first equation? F minus T is equal to m into A is the first equation. Second equation, T is equal to mass into acceleration, second equation. Solving these two equations, then you will get the acceleration and external force. Okay. So from these two equations, then you will get the tension in the string is nothing but that is F by 2. And here two masses 8 kg and 12 kg are connected at the two ends of a light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when masses are released. So here this is 12 kg and that is 8 kg. So first draw the free body diagram of the 12 kg and free body diagram of the 8 kg. I am drawing the free body diagram of the 12 kg here. This is the 12 kg. 12 kg weight acting vertically downward direction. So what is its weight? That is m into g. 12 into g acting downward direction and tension T is acting upward direction. So here this 12 kg mass is more than the 8 kg mass. So that's why 12 kg mass is moving downward direction. So here acceleration acting downward direction. So what is the equation? Newton's second law is what? F net is equal to mass of the body into acceleration. What is the mass of the body? 12g minus T is equal to 12 into A. This is equation number 1. And next 8 kg mass free body diagram. This is 8 kg and 8g acting vertically downward direction, and here this tension T is acting upward direction. 8 kg body moving upward direction because this mass is less compared to this 12 kg. So that's why the net force acting on the 8 kg body is in the upward direction. So here T minus 8, this is the T and this is 8. So T minus 8 into G is equal to 8 into A, equation number 2. Adding these two equations plus T minus T, 12G minus 8G is how much? That is 4G is equal to, that is 20 into A is equal to 4G divided by 20. Suppose take G is equal to 10 and 40 divided by 20. So that is equal to 2 meter per second square is the acceleration of the object. A is equal to 2 meter per second square. Substitute this A value either in equation number 1 or either in equation number 2, then you will get the tension. Suppose from the equation number 2 implies So T minus 8G is equal to 8A, T is equal to 8G plus 8A, that is 80 plus 8 into, what is the acceleration is 2, that is 80 plus 16, that is 96 Newton is the tension in a string. So acceleration is 2 meter per second square and tension is 96 Newton. So tension is 96 Newton and acceleration is 2 meter per second square. This is about the Newton's laws of motion detailed part. Okay.